Well, let's do this. Let's try this. There it is. All right, so looking at this first one, old school, old school. What the heck do I do to evaluate this if I know this? Substitute it in. So if I know that x is going to equal 2, I can substitute that in place of the x. In place of, not next to. So we're going to take this 3 and substitute in that 2 right here in place of the x. And then we add 4. And then we're into order of operations. What are we going to do first? 2 times 3. That's going to give us a 6. Plus 4. Which means when x is 2, our answer here is 10. We substitute the pieces in, and then we're going to simplify. We do the same thing for our x equals negative 3. If I know x equals negative 3, I can substitute that in place of the x. I wonder what we're going to work with today when we're doing mathy things. What? We're remembering how to do the substitution stuff? I wonder if that's going to be relevant. What? I'm muttering to myself. Because I wonder if we'll remember how to substitute stuff for reasons. Whenever I substitute something in, I put them in parentheses like this. It really helps us remember that this is 3 times negative 3, not 3 minus 3. So 3 times negative 3 is going to give us what? Negative 9. It's going to give us a negative 9 plus 4. What is negative 9 plus 4? Negative 5. Ooh, that's not a line. Negative 5. So when x is negative 3, our answer is negative 5. So we can substitute things in place of variables. I wonder why we had a problem from Algebra 1 about that stuff. Huh. Relevance. We'll get there. All right, the one on the right is very much a review of what we did yesterday. We're going to find our solution by graphing. So that means I need to graph both lines. So I'll do this top one in green. This is in our slope-intercept form. So what's my intercept? Where do I start on this one? 3. Not 3. On the y-axis. Every time it starts on the y-axis for our slope-intercept form. How do I get to my next point? Down 1, right 2. So we're going to go down 1, right 2. Down 1, right 2. Down 1, right 2. I could also go up 1 and left 2. That would also work. Helps to fill in a few more dots. The more dots you have, the easier to connect them up. Using a ruler, since we are trying to find out where they cross, where the intersection is, means I need to actually be able to tell where things are supposed to be. So use a ruler. There should be some at the tables, either on the tables or in the cups on the front of the tables. Depends on how clean I got your table. These are our spots. If you ever need a ruler and you're not out, there's some over on the wall over here by the calculators. So graphing one line is great, but it does not tell me where the solution is. We have to graph both lines. We have to get all the way to the graph of both lines. Even if you spot the intersection, still finish the graph. On this one, where are we going to start? Negative 4. And how am I going to find my next point? Up 3, right 1. So up 1, 2, 3, right 1. Up 1, 2, 3, right 1. Oh, look, that's what we found. Up 1, 2, 3, right 1. Again, plotting up our point, connecting them up, even though I've already spotted where I think the answer might be. Plot both lines all the way. And then we find our solution. Where is our solution going to be? 2, 2. This guy right here, it's where they cross. This is the solution. It is the ordered pair. I'm going to just do this. Write this one. 2, 2. Just because I didn't have a place to write it better. So it's all about the place where the lines cross. Our answer is going to be a set of points, or a point. Okay. Questions on that one? Okay. So we are going to be working in the notes packet today. Shock. And we're going to work on solving systems. So we're going to find more things like this where we're finding our point where the lines cross. But today we're going to do it without graphs. Today we are going to do this with substitution. Oh my gosh, relevance. All right, so we are on page 11 in your packet. And we're solving systems equations, but not by graphing. That's how this starts. We're going to solve them what's called algebraically. And so our first option is to solve things with substitution. And it works very, very much like what we did in the bell work, where we knew x was 3, I could substitute that in. But instead of this time us knowing x is 3, we're going to know x is something like maybe 3x, or 3y, or 2x. And we're going to substitute those pieces in. So this gives us some steps right here. We have options when it comes to solving. We're going to have another option that we're going to look at tomorrow. And we can use either technique to solve any of these. It's going to be a matter of which ones are easier to work with for that particular style of problem and which ones we like better. Because sometimes it's just freedom of choice. So our first step is going to be, if we need to solve an equation for one variable, meaning I need an x equals or a y equals. Either one's fine. Then we're going to substitute into the other equation, and then we're going to solve to get our point. Just like with the graphs, our solution needs to be a point, an ordered pair, x and y. So we will get an x equals, and then we will have to substitute back in to find our y equals. So we need to have both. Our solution has to be an ordered pair. That was not the highlighter. Has to be an ordered pair. So our answer has to be that parentheses, both numbers, close parentheses. So we're going to look at example 1 here on how to do this. We're going to use substitution to solve this. So we're going to be given two equations, just like we were when we started graphing these. But one of these is already set to be a y equals. So we know that y is actually going to equal 5x plus 3. If we know that y equals 5x plus 3, what we're going to do is I'm going to come into this second equation, and I'm going to substitute that in place of this y right here. So I'm going to say, I don't want to have both x and y in here because I can't solve it when it has two different letters. But if I know that y is going to equal 5x minus 3, I'm going to squish that in right here so that we can get this all down to one letter. So when we do that, we're still going to have our 3x minus 2y, but instead of a y, I'm just going to put a big set of parentheses, equals minus 8. So it's still the same equation, and if it helps, and if you're using pencil, you could put the y in here. Just give them some room. But we don't actually want to have the letter y there. We're going to replace that y with what we know y equals up here. We're going to replace it with our 5x minus 3. Those are not different enough colors. I will pick different colors. Okay, so I'm going to substitute the first equation into the second equation. Whichever one we have is an x equals a y equals, we're going to substitute that in. The benefit of doing that is now this thing only has one letter, which means I can simplify this and get all the way down to an x equals. In order to do that, I need to get rid of my parentheses, so I'm going to need to do some distributing here. So we're going to have this 3x that stays the same, and then we're going to take that minus 2 times 5x. Minus 2 times 5x gives us minus 10x. And minus 2 times minus 3 gives us plus 6 equals negative 8. So we're going to distribute to get rid of those parentheses. Whenever we have a minus sign outside, distribute that with it. What can I do here now? If I want to get all the way down to an x equals, what do we need to do? So ignore where this came from. Just do that part. What should we do next here? Yeah, we can minus the 6. We can also combine a couple of like terms. I've got 3 x's and I'm going to take away 10 x's. What's that going to leave me with? What is 3x minus 10x? It's going to be a negative 7x. And you can do that in the calculator, 3 minus 10. You just can't put the x in. And then if we minus that 6 from both sides, minus 8 minus 6 gives us a minus 14. I'll put it back on the whole page. Because we only have one step left to find our x here, what do I need to do? How do I get x by itself? By? Good catch. Yep. Negative 7. If we divide both sides by negative 7, then this guy and that guy cancel out. That's the whole point. They turn into a 1. That's what we want. I want to know what 1x is. So it's just our x. What is negative 14 divided by negative 7? It's a positive 2. So by putting that first equation into the second equation, I can figure out my x's too. But remember, I don't just want x for my solution. I need both, the x and the y. So what we're going to need to do is we're going to need to substitute back into one of these equations to figure out what y is. You absolutely can use this one, but that's going the hard way when I have a literal y equals equation. I can just substitute into this guy when I know my x is 2. Then we're exactly into what the bell work was. I know my y is going to equal our 5x minus 3. But instead of a letter x, we're going to substitute in the x we got. I want to know what y is when x is 2. So we can, again, simplify this out. Our y is going to be 5 times 2, which is 10, minus 3. What is 10 minus 3? 7. So our answer, our final answer on this one, our solution to this system, the point where these two lines cross is the point 2, 7. X, then y. So we don't have to do these by graphing. We can do these algebraically. We need an x equals or a y equals, and then we can smush them together. Questions on this first one? Because we're going to do more. This is something we use a lot, is substitution. Okay. Then let's look at the next one. It's lower on the page. Bottom half, we've got y equals 5x minus 10, and 2x plus 2y equals 124. We already have this one set up with a y equals. Here I know y equals this 5x minus 10. It's very similar to the one we had before. So when we're looking at our second equation, I want to replace the y with this thing I know about y. I know my y is supposed to be 5x minus 10. So down here, I'm going to replace this y with that little piece. So I'm going to come down here and replace this y. So when I write this out, we're going to have our 2x plus 2 times y, or 2 times something, equals our 124. And for some of us, it will really help to write it like this and take a step back for a second, because we need to make sure we get the whole equation there. 2x plus 2y equals the 124. That green equation, my y equals, is going to go in place of the y. Nothing else is changing. I'm just taking the 5x minus 10 and putting it where the y used to be. Pick it up and squish it in. Once we have them smushed together, then we're ready to simplify. It doesn't matter what else is up here. This is all we're looking at. What do I need to do first to simplify here? How do I get down to an x equals? Distribute, exactly right. I need to take this 2 to the 5x, and I need to multiply this 2 to the minus 10. So we're going to have our 2x plus 2 times 5x gives me 10x. 2 times minus 10 gives me minus 20 equals 124. Now what should we do? What should we do next? Combine like terms. I've got a 2x plus 10x. That's going to give me 12x minus 20 equals 124. What should we do next? Add the 20. Add the 20 of both sides. Absolutely right. Absolutely right. I want to get down to an x equals, which means I need all my numbers to go to the other side. So that's going to leave us with 12x equals 144. Divide. We're going to divide both sides by 12, because I want to get that x by itself. So what do we get? What does our x equal? 12. 144 divided by 12 is 12. So that gives me part of my answer. I know my x is going to be 12. But we also need to know our y. I need to know what my y equals, what y is, because my answer has to be a point. X equals 12 is a line, not a point. That is not a solution. It is half of a solution. It is not the whole thing. So we need to figure out what our y is as well. So we're going to take our y equals equation and write it with a pen. We know our y is going to equal our 5x. So 5 times something minus 10. But we know what x is going to be. X is going to be 12. So I'm going to substitute that in. Just like we did in the bell work. What? Oh my God. So then we're going to simplify this. Y equals 5 times 12 is 60. So then we have 60 minus 10. Y equals 50. And thus why we have this as part of our options for solving is because if I was trying to solve this with graphing, I would need a really big graph paper to be able to get up to y equals 50. because our solution where these two lines cross is going to happen at the point when x is 12 and y is 50. With our comma between them, close parentheses. This is how our solutions need to get written. As an ordered pair, x then y. X equals 12 is half a solution. Y equals 50 is half a solution. Even if they're written like that, it doesn't count as a whole solution until you write it as a point. As a point. Okay, questions on this one? Done two now. We don't always get handed a y equals. So on this next one, we don't have a y equals. But we do have an x equals. That's okay. We can do that. It's the same kind of vibe. Here we have that x equals y minus 2. And our second equation, 4x plus y equals 2. It doesn't matter that we have x equals. I can still take the fact that I know that x equals this and substitute it in place of the x. They mean the same thing. I could swap it out. So we're going to take whatever our variable equals and we're going to substitute it in place in the other equation. So it doesn't matter if we have an x equals or if we have a y equals. We can do it with either one. We just have to be careful and intentional. Because when we put these together, we're going to wind up with our 4 times something plus y equals 2. Because that x is what we're going to substitute into. So that's why I'm going to put in my y minus 2 in place of the x. So we're smushing these two equations together. Now that we look at this thing, this one only has y's in it. So we're going to actually be able to solve this. When we substitute this in, if it still has 2 letters, we did not substitute correctly, or we did not have an x equals or a y equals. We have to have an x equals or a y equals to be able to do this. Have to. If this has more than 1 letter, something went wrong. Morning. So now we're ready to simplify this. Thank you. I need to do my distribution over here. I'm going to have my 4 times y, giving me my 4y. My 4 times minus 2, that's going to give us a minus 8. Then we have this plus y equals 2. So we're going to start by doing any distribution we need to. Then we're going to work towards solving. I want to get down to a y equals here. What do we need to do next to solve this? I've got some like terms we could combine. If I have 4 y's and I add another y, that's going to give me 5y minus 8 equals 2. What can I do now? How do I get down to y equals? Add the 8. That's going to give us that our 5y equals 10. Because if I add 8 here, I need to add 8 here. And then to get my y by itself, I want to get my y equals, what is my y going to equal? 2. So I need to divide both sides by 5. And 10 divided by 5 gives me 2. Whereas 5 divided by 5 just gives me a 1. So now we know our y is going to be 2. Great. I still need to know what my x is in order to be able to find my solution. We need the point where they cross. So this is great, and that is part of my answer, but I need to know x as well. I could use either one of these equations. It doesn't matter. Genuinely, it does not. But since I have one that's just going to spit out my x equals, I'm just going to use that one. So we know that my x equals whatever my y is minus 2. Well, right now I know my y. My y is 2. Well, those parentheses aren't actually doing me any good. I don't need to multiply anything there. So if my x is just 2 minus 2, what's my x going to be? 0. 0 is a fine number. Like, I'm allowed to have $0. That's a thing. We can have 0. Just because we get a 0 doesn't mean something's wrong. I don't know why, but people start panicking when we get zeros and we think we're wrong. It's okay. 0's a thing. So this gives me my x of 0. And I know my y is going to be 2. So my whole answer is going to be the point 0, comma, 2. It is always x, then y. Alphabetical order. X, Y, Z, X, then Y. They're always in alphabetical order, X, then Y. As an ordered pair, with the parentheses. Zeros are an okay thing to be. We just kind of accidentally wound up on our y-intercept. Okay, questions on this one? Cool. Let's look at this guy. So here's the third one on that page. This time they didn't just hand us an x equals or a y equals. There's not one straight up written nicely for it. But if we have here our 8x minus 3y equals minus 1, it's fine, but I don't see anything nice in there. Here I have x plus 2y equals negative 12. I see a variable in here that's very, very close to being x equals. If I just have one x and I want to do some substitution, I can make this be an x equals. What do I need to do to this equation to make it be x equals? Minus the 2y. If I minus 2y from this side and minus 2y from this side, I'm going to get x equals, and you can either write it as minus 2y minus 12 or minus 12 minus 2y. It genuinely does not matter. Minus 2y minus 12. So by doing one single operation, I made this be an x equals. Because now that I know that this is an x equals, and I actually do have something that we can work with, I now can take this x that I know is going to equal this and substitute it in place up here. I have to make sure I substitute into the other equation. If you take this x equals and put it back here, you're going to wind up with an infinity answer because you put the same line twice. So this needs to substitute into my other equation. But we can absolutely do that. So I'm going to substitute this x equals that we made into this top equation. So we would typically have our 8x, that's 8 times something. That x is what we're replacing, so I'm just going to put a set of parentheses there. 8x minus our 3y equals negative 1. But instead of having just the letter x, we're wanting to substitute in that expression that we found, or the equation we found, that minus 2y minus 12. We're substituting that in place of the x. Once we have an x equals, we can do that. And this guy was going inside there. That's what we were putting in. And now we can do some distribution to kind of try and simplify this stuff. I'll need my 8 times that minus 2y to get minus 16y. And we're going to have 8 times minus 12 early. We don't have to math it with our heads. We've got calculators. 8 times minus 12 is going to give us a minus 96. And then we have our minus 3y equals negative 1. As a reminder, whenever we are distributing the closed parentheses, these guys right here, that's our stop sign. When you start distributing, you stop whenever you get to a closed parentheses sign. I don't care if you have more parentheses this way, you stop. That's your stop sign. The 8 does not go to the 3 or the minus 1. It just goes to the guys in here. So stop at your closed parentheses. I've had a lot of people go distribution crazy, and we have just given everybody everything. Closed parentheses is your stop sign. Then we can do some combining like terms. I've got minus 16y and minus 3y. So if I owe you $16 and I owe you $3, grand total, I owe you 19, minus 19. If we think about it as money somebody owes us, we're so much better with those negative numbers. So think about it as somebody's owing me money, or I owe money. You know, pretty decent if I keep track of that too. Equals our minus 96 equals minus 1. What do you want to do next? There's options at this point. Add 96 is a valid option. Plus 96. So that's going to give us our minus 19y equals negative 1 plus 96 is going to be a positive 95. Unpleasant. How do I get the y by itself? Divide by our negative 19. Good. Make sure we keep track of that sign. So we're going to divide by negative 19. It's really important that we keep track of those signs. It makes a huge difference. Our y is going to equal what? What is 95 divided by negative 19? Negative 5. That gives us part of our answer. Now we need to find our x's. We can't just have the y. We need to find the x as well. So we could go into the top equation. Don't want to. Could go to the second equation. But I don't really want to. I want to use this guy because I have an x equals. I can just plug and chug and get my answer. No solving steps required, just simplifying. So even though I made this equation, I can still use it to find my x. Because we know that our x is going to equal negative 2 times whatever our y is minus 12. But now we know our y is negative 5. We're going to have our negative 2 times our negative 5 and then minus 12. Well, negative 2 times negative 5 is going to give us a positive 10 minus 12. What is our x? Negative 2. So our solution to this system, the point where they cross, is going to be the point negative 2, that was my x, and my y, which is negative 5. So we're still finding that point where they cross. Okay. We're going to do one more on the next page, and then we'll do the stories tomorrow. So example 2 here from the textbook, because they have this without all the stuff in between, because they're so easy. And this is already 3/4 of the way set up for us. It's written at the top. We just kind of want to see what's going to happen on these ones that are unpleasant. We have our minus 5x plus 2.5y equals negative 15. Unpleasant, but it's a thing. We can have decimals. And then they've given us our y equals 2x minus 11. Since we have a y equals already, they've told us let's do this with substitution, and we're going to substitute that thing in for y. And they've started the process down below. They write really small, but they've started it. They've gotten our minus 5x plus 2.5y equal to negative 15, and they put the big set of parentheses here. So we're just figuring out what is going in place of this y. Well, we already know what y equals. Y equals that 2x minus 11. We're substituting that piece in place of the y. They just draw it with a box because they're hoping we're going to click on it, I guess. I don't know. Then what we can do is we're going to do our distribution. Even though it's decimals, we can do that. It's not pleasant, but it's a thing. 2.5 times 2 is going to give us our 5x. They already have the x written right here. It's just really hard to see. And then we're going to have our 2.5 times this minus 11. And we get 27.5. So I'm just going to rewrite this line because I don't like the way they've written it here, where we have our minus 5x plus 5x minus 27.5. Because what happens when I combine together my like terms? There we go. What happens when we combine together our like terms here? They cancel out. I have 5 apples, I give away 5 apples. I have none apples left. I have no x's left. My x's go away, and we're left with just our minus 27.5 set equal to negative 15. Does negative 27.5 equal negative 15? Is that ever a thing that happens? Is me owing you $27 the same as me owing you $15? If so, be my new bank. No? Oh, darn. Thought I was going to find a new bank. So if we get something that is inherently false, I can't do this. This is not real. This is when we are going to have those no solutions. Okay? So we can work with an x equals, we can work with a y equals. If we get something where we have no more x's and we get something false, that's when we have no solution. If I get something where I have no more x's or y's and I get something true, like 3 equals 3, that's when we get our infinitely many solutions. We'll look at the story problems a little bit tomorrow, and then we're going to look at our other technique that we have for solving these things. I'm going to give you guys homework 5. It is currently listed as due on Thursday. It may wind up being Friday. Depends on how we get through tomorrow and how our speed is. So I'm going to give it to you. The ones we've done are these top 3. We have not done most of the rest. So there's a little bit of review on the back that you guys might be able to do. But we have not really done the bottom half of the front side. So that's what we're going to talk about tomorrow. So I'm going to pass these out. And then it's going to be just about time that they do the church for the announcement. This one is over what we just did. The top 3 are the substitution we did. The bottom 3 are what we're going to talk about now. It's called elimination. And it's just another option for solving. It's doing the same thing, finding that point. But it's just sometimes they're set up really nicely for an x equals y equals, and sometimes they're really not. And we would really rather not deal with fraction grossness.